Introducing the structure and the execution of Ruby programs. This explains the structure of Ruby programs. It starts with the lexical structure covering tokens and characters that comprise them. Next, it covers the syntactic structure of a program written by the Ruby, explaining how expression, control structure, methods, classes, and so on are written as a series of tokens. Finally, the video describes the files of Ruby code, explaining how Ruby programs can be split across multiple files and how the Ruby interpreter executes a file of Ruby code. The lexical structure. The Ruby interpreter parses a program as a sequence of tokens. Tokens include comments, literals, punctuation, identifiers, and keywords. This section introduces these types of tokens and so on, includes important information about the characters that comprise the tokens and the white space that separates the tokens. Comments. Comments in Ruby begin with a hash character and continue to the end of the line. The Ruby interpreter ignores the hash character and any text that follows it, but does not ignore the new line character, which is meaningful white space and may serve as a statement terminator. If hash characters appears within a string or regular expression, literal identity is simply part of the string or regular expression and does not introduce a comment. Literals. Literals are values that appear directly in Ruby source code. They include numbers, string of text, regular expression. Other literals such as arrays and hash values are not individual tokens but are more complex expressions. Ruby numbers and string literals syntax is actually quite complicated. Case sensitivity of Ruby programs. Ruby is a case-sensitive language, and lowercase letters and uppercase letters are distinct. The keyword end of a file is completely different from the keyword capital, which starts with capital E followed by capital N and D. Identifiers. An identifier is simply a name. Ruby uses identifiers to name variables, methods, classes, and so forth. Ruby identifiers consists of letters, numbers, and underscore characters, but they may not begin with a number. Identifiers may not include white space or non-printing characters, and they may not include punctuation characters except as described here. Identifiers that begin with a capital letter A to Z are constants. The Ruby interpreter will issue a warning but not an error if you alter the values of such an identifier. Classes and modules name must begin with initial capital letters. The following are identifiers. Keywords. The following keywords have special meaning in Ruby and are treated specially by the Ruby parser. In addition to those keywords, there are three keyword-like tokens that are treated specially by the Ruby parser when they appear at the beginning of a line. They equal followed by begin, equal followed by end, and hyphen end followed by hyphen. As we seen, equal begin and equal end at the beginning of the line delimit multi-line comments, and the token underscore followed by end followed by underscore marks the end of the program at the beginning of the data section if it appears on a line by itself with no leading or trailing white space. In most languages, these words would be called reserved words, and they would be never allowed as identifiers. The Ruby parser is flexible and does not complain if you prefix these keywords with at or double ats or even $mark prefixes and use them as instance, class, or global variable names. Also, you can use these keywords as method names with the caveat that method must always be explicitly invoked through an object. Note, however, the using these keywords in identifiers will result in confusing code. The best practice is to treat these keywords as reserved. Now we're going to look at data types and objects. In order to understand a programming language, you have to know what kind of data it can manipulate and what it can do with that data. This section is about values manipulated by Ruby programs. It begins with comprehensive coverage of numeric values. Next, it explains arrays and hashes, two important data structures that are a fundamental part of Ruby. Numbers. Ruby includes 5 built-in classes for representing numbers, and the standard library includes 3 more numeric classes that are sometimes useful. All numbers of objects in Ruby are instances of numeric. All integers are instances of integer. If an integer value fits within 31 bits or on most implementation, it is an instance of fixed num. Otherwise, it is a big num. Big num objects represent integers of arbitrary size, and if the result of an operation of fixed num operands is too big to fit in a fixed num, the result is transparently converted to a big num. Similarly, if the result of an operation on big num objects falls within the range of fixed num, then the result is a fixed num. Real numbers are approximated in Ruby with the float class, which uses the native floating point representation of the platform. The complex big decimal and rational classes are not built into Ruby but are distributed with the Ruby as a part of the standard library. The complex class represents complex numbers. Of course, big decimal represents the real numbers with arbitrary precision using a decimal representation rather than a binary representation. And rational representation represents rational numbers, one integer divided by another. Arrays. An array is a sequence of values that allows values to be accessed by their position or index in the sequence. In Ruby, the first value in an array has index 0. The size of the len methods return the number of elements in an array. An array literal is a comma-separated list of values enclosed in square brackets. Hashes. A hash is a data structure that maintains a set of objects known as keys and associates a value with each key. Hashes are also known as maps because they map keys to values. They are sometimes called associative arrays because they associate values with each of the keys and can be thought of as arrays in which the array index can be any object instead of an integer. An example makes this clear. The hash this hash will map the names of digits to the digits themselves. Now we look at the statements and the control structures.